Hello everyone. Today I want to talk about a very simple technique using the tile control net that we can use to upscale images. This is a very simple and effective method that consumes very low VRAM for upscaling images. This is a very handy tool that we can integrate into our existing workflows, whether for image generation or even video workflows. We can do this without limiting ourselves or the computer regarding how much VRAM is needed to generate. For example, if we have videos of 10 seconds, we can upscale them. Some upscale models will consume a lot of memory while upscaling and may cause our ComfyUI to stop, prompting an error message that says out of memory, etc. Right here, I have a very simple image-to-image workflow. As you can see, if we are upscaling using a normal method without the tile control net, there will be a slight difference in the face compared to the source image, and even some details on the characters and backgrounds will be different. Even if we set the denoising strength very low, it will still affect the output image slightly. So if we want exactly the same image like this one, we can upscale it 4 or even 5 times its original size while retaining the same faces and details. Instead of using image to image or a standard upscaler, which may sometimes cause problems, especially with the ultimate upscaler, we can use a different method. The ultimate upscaler can cause the output image or video to differ slightly from the original. How do we avoid that? First of all, SDXL models are a pretty good way to start. Secondly, we can use the SDXL Tile ControlNet, which we mentioned before. The same author created this ControlNet, and although the ControlNet++ tends not to emphasize tile support, we can still test both methods. I will be using the ControlNet Tile SDXL, which focuses more on tile ControlNet data. To start, you have to download this custom node called ComfyUI Tile Diffusion. This will enable you to use SDXL models for image-to-image upscaling and ultra-large image generation. The Tile Diffusion model has its own custom nodes for model data input and output. We can leverage this, along with the tile's VAE, to produce extra-large image outputs. So we've got the VAE encode and VAE decode that are specified for the tile's model. Let's try this. Basically, there will be 3 custom nodes here that we will be using in a ComfyUI workflow. I tried to make it as simple as I can so we don't have a complicated workflow that not many people will understand. Here we have the VAE encode tile, which will be putting the pixels and the VAE here. Once we're done, we can just connect the latent image data that will replace our typical VAE encode custom nodes. Secondly, we will be replacing the VAE decode. We type the code and search for this one. Then we have the latent samples data connected here. Next, we have the VAE data for the red dot. After all this, we get the final image output for our result. Now we need another one, which is the Tile Diffusions model, which is here. This one will go before the K-sampler. So this will happen before the K-sampler, which connects the model data. Here we've got this model's data, and there are some options you have to configure. Each AI image might work differently. We've got the mixture of diffusers and also the multi-diffusions. Here, I will choose the multi-diffusions just to try it out. The tile width and height and the tile overlap, I will leave the same. But for the width and height, I will convert them as inputs and make them dynamic by converting the math of that. So, what I will do here is convert the tile width and the tile height for input parameters. Right here, we will do a math operation to multiply how many times from the original image. For example, if I have this image here, I need the image info to calculate the original image's width and height and determine how many times we want this generated image to be upscaled. So at the top, I have done a simple calculation. First, we retrieve the input image from the load image node. We pass the image data to these getImageSize custom nodes, and we will retrieve the width and height of this image, passing them to point A of each of these custom nodes for simple math. We have an integer for passing the values of how many times we want to multiply the width and height values. Finally, we will have those values, calculate how many times we want to upscale the width and height, and pass it back to the Tile Diffusion's input parameters. This will be a very easy and simple way to work on. We don't need too much complex stuff to make this happen. So imagine we have, let's say, 3 times the width and 3 times the height. That way we can do something like this. Or if you want to make it even simpler, we don't need this integer. Maybe we can connect both b values to this integer custom node. That will be easier. So let's say we want to set how many times we want to upscale. In this case, 3 times. Then we can try this time to run this. Lastly, we need to add a control net, because the models, of course, are going to be the tile. So, just like a normal control net, we apply the control net tile. This time, it is SDXL control net models. We have the apply control net here using one condition, and that will be it for connecting your control net positive into here. We will have both the positive text prompt and the negative text prompt as well. So we only need to take care of the positive prompt. Then this will be the whole set of control net settings for here. The upscaled image will again get the width and height based on the map that we have in this formula. That will be the output of the image for the tile control net. Lastly, we have the condition of the positive connected to the K sampler. After making sure everything is connected, we have to check the upscaled image. The output image from here must be connected to the VAE tile pixel data here. That will allow the sampling steps to produce the upscaled size of the image. I have removed the sample, the tile width and height here, just to try it out with just the upscaled image this way. But of course, alternatively, you can use the convert tile width and tile height. Put this back together as it is from these two values. This will make it more tightened up and accurate. We also have to change the K-sampler to the K-sampler advanced. This will allow us to get more control of the start sampling and the end sampling steps. Also, we will have more control over the noise and other features here. Lastly, we have the tile decode again. I found out that this one can be a fixed size, whatever tile size it is, and it is fine. Usually, we use 512 for SD 1.5 and 1024 for SDXL. Lastly, we will have the image output as a preview image. That will be our result here. So let's try using this image one time, and we can generate it with the whole workflow here. Meanwhile, it is processing the image upscale. I have added one more thing here for the text showing, just to make it easier for you to know the actual result after multiplying the width and height. Here, this is the height of the numbers for the upscaled height. Here we have the upscaled width size, showing us a display string number that will make it easier for us to recognize the size of this upscaled image. This will take a while because it is over 3000 width and 2000 height pixel size. It will take some time for sampling, but for quality image, it is worth it to upscale each pixel without any sampling steps changing your image. We will see how exactly it will be the same as the original image. Here we have the output image after the tile upscale. We can see that it is 3 times larger than the original image. That's the actual size of this. As you can see, both the normal size image and the upscaled size image remain the same in everything from the character itself to the background, and even the outfit and clothing are the same. This is a better way to upscale an image and keep the original elements of the source image rather than using some upscale models. Sometimes going through the sampling step will change the face of the image character or even some backgrounds. This is something we don't want in some situations, but in this case, it's pretty good. All the details are very coherent with the original source image. We have maintained the same face as in our original image. So this is a simple workflow, very easy to use. We just use the ControlNet to do an upscale. ControlNet can do a lot of things, not only for creating a new pose of an image. This is the Tile Diffusions and the Tile ControlNet use for upscaling an image. I hope this inspires you guys, and I will see you in the next videos. Have a nice day. See ya!